Hi everyone. Synthetic division is a shortcut alternative to long division when the divisor is very nice, something of this form, x minus k. So let's take a numerator, a polynomial f of x in x. And we're dividing it by, let's say, x minus 2. We can then use synthetic division. We're dividing by x minus k, where k is what number? Where k is 2. Now let's say we have a problem like this over here. Our example here, we're dividing f of x, this top guy here, and there's a reason why I'm calling it f of x, by the way. And we're dividing it by x plus 3. Now here, we're dividing by x minus k, where k is what number? Where k is negative 3. So there's a sign flip. Why do we have a minus sign here, and why are we playing this sign flip game? We'll see in just a moment. But again, synthetic division is an alternative to long division where you're dividing a polynomial in x, say, f of x, by something of the form x minus k. So when you write down k, there is a sign flip. This value for k, I'm going to put in a half box. I call it a dunk tank, like at a carnival. Again, if you're dividing by x plus 3, k is negative 3. Because x plus 3 is x minus negative 3. K is negative 3. So here's what we're going to do. I'm going to put negative 3 in the dunk tank, and we're going to take the leading coefficients of f of x, this top polynomial here. And what are the coefficients? Let's be careful. What are the coefficients of f of x in the descending powers form? What's the leading coefficient? The leading coefficient is 2. Now, what's the next coefficient? Now, be careful. When I say the next coefficient, I'm asking for the coefficient of x squared. 2 is the coefficient of x cubed. It's the leading coefficient. But now I want the coefficient for x squared. What's the coefficient on x squared? It's 0 because there's an implied missing term, plus 0x squared. In fact, I am strongly advising that you write down that missing coefficient for the missing term. And then we have, watch your sign, for the x term, the coefficient is negative 3. And for the constant term, it's kind of like x to the 0, right? The coefficient for x to the 0 is 5. It's the constant term. All right. So our first row, when we do the synthetic division, we put the negative 3, the value for k here, in the dunk tank. And then we put the coefficients based on the descending powers form, right? But you must put the 0. You must put that 0 there, corresponding to the missing term. If you put 2, negative 3, 5, that's going to be wrong. You have to put 2, 0, negative 3, 5. You absolutely need this. I don't care who you are. You need it to show your work. Okay. And then we leave the second row blank for now. And then we're going to produce the third row. Now, how do we get the third row? We begin by bringing down the 2. And by the way, this is really a shortcut to the long division. So if you want to know why this works, this is going to seem like magic. If you want to know why this works, work out the long division, and you're going to see the patterns as you work these things out. All right, the 2 comes down. We put a 2 to start off our third row. And then what do we do? Okay, we're going to go on a diagonal from here to here, and we're going to multiply by k, the number in the dunk tank. K is negative 3. What is 2 times negative 3? 2 times negative 3 is negative 6. So we put a negative 6 over here. And then you add down the column. A 0 and a negative 6 is just a negative 6. So remember, you multiply diagonally to get over here in the second row, and then you add down to get the entry in the third row. Repeat the process. What's negative 6 times k? The negative 3. When you multiply by negative 3, I'll write that. When you multiply by negative 3, negative 6 times negative 3 is positive 18. Again, we add down the column. You're in Vegas. You lose 3, you win 18, you're still up 15, positive 15. I know that's joke money in Vegas, but bear with me. Along the diagonal, we multiply by k again. We multiply by the negative 3. I'll put this over here as well. So to get the 18, remember that was negative 6 times negative 3. That gave positive 18. And now we're asking, what's 15 times negative 3? A calculator can help. What is 15 times negative 3? That's a negative 45. Okay, you're in Vegas. You win 5. You've lost 45. Bad hand. You end up with a negative 40 over here. And I'm going to circle that. It turns out this is going to be our value for R. Guess what R stands for? R stands for remainder. Negative 40 is going to be our remainder. So in the end, we care about this bottom row, row number 3. Okay, so when I divide the top polynomial by the bottom polynomial, well, first of all, look at it this way. Think in terms of degrees. We're dividing a third degree polynomial by a first degree polynomial. What degree will the result be? I'll give you a hint here. What is x to the third divided by x, or x to the first? What's x to the third divided by x to the first? It's x to the second. When you divide powers of x, you subtract the exponents. In general, when you divide a third degree polynomial by a first degree polynomial, in general, your result will be second degree. You subtract the degrees. All right. So, see, when you divide the top polynomial by the bottom, what's going to be the leading term of our result, our quotient? Well, third degree divided by first degree gives us second degree. The 2 here is going to be the coefficient for the x squared term. 2x squared. And then the negative 6 will be the coefficient on x, negative 6x. Plus the 15 over here. Okay. And then plus, what's the scheme? Remainder, the negative 40, over the divisor, which is way over here, x plus 3. Squeezing that in there. X plus 3. And then you can pop out the minus sign. All right. And you would have gotten this from long division as well. By the way, the remainder has to be a constant because when you're doing synthetic division, we're assuming that the divisor is linear, first degree. which means that the remainder better be a constant, either 0 or something with degree 0. Let's recap the process. All right. Bring down the 2. You multiply by k, -6, add down, -6. Multiply by k, you get +18, add down, you get 15. Multiply diagonally by -3, you get -45, add down, you get -40. This is r, the remainder. Use these as the coefficients of your quotient. It's going to be a second-degree polynomial. Basically, the degree goes down by 1. When you divide an nth degree polynomial by a first degree polynomial, which is always the case with synthetic division, the result will have degree n-1. You drop the degree by 1. All right, so we get, oops, whoa. So we get 2x squared minus 6x plus 15. This is very convenient. Again, if you don't believe me, work out the long division. Okay, plus -4 over the divisor, but the negative sign can pop out. Remember, over here, we had plus -40 over x plus 3. The minus sign can pop out, so we can get minus 40 over x plus 3. If the remainder is negative, it's conventional to pop out the -1 factor. So we normally write this as 2x squared minus 6x plus 15 minus the fraction, positive 40 over x plus 3. Right. And this is typically simplified. Again, ideally, this would be what? It would be great if the remainder were what number? It would be great if the remainder were 0. Then we get a polynomial as our result. So remember, a 0 remainder would be great. This would drop off. We just have a polynomial. All right. Next, we're going to talk about the division algorithm and the remainder theorem.